In this lesson, we'll be talking about how to use properties of exponents. In front of you, we have a list of all the various properties that we will be using with these exponents. It would be a good idea to write these definitions and examples down as I go over them. So the first property is a product of powers. Product meaning multiplying, and then powers, well, with exponents. And basically, if I have a times a to the m power times a to the n power, we're going to add the exponents together. So that's going to be a to the mn. So if I had 5 to the third times 5 to the negative 1, then that's going to be 5 to the 3 plus negative 1, or 5 squared, which would simplify to just 25. Um, the next one is a power of a power. Basically, we have an exponent, in a sense, on an exponential expression. So I have a to the m, and then that's all to the n power. In other words, um, if if I had like 3 cubed, and then I was going to square that. So in other words, I'm having a to the mn. I would multiply them together. And so in other words, here I have 3 cubed squared. Well, I would multiply them together. The reason for that is I'm saying I have 3 cubed, and I'm squaring that, so I have 3 cubed. So I have 3 cubed times 3 cubed. So since I'm multiplying them together, that's going to give me 3, and then add those together, giving me 6. So 3 to the 6. And that's the same thing that we see here as 3 to the 6th power. The next one is a power of a product. So here we're going to be multiplying two numbers together, and then applying that an exponent to both of those. And this is kind of a deceptive one. It looks like you're using the distributive property, but please write this down somewhere. Exponents do not distribute. This is very important. Exponents do not distribute. It's very deceptive. It looks like the distributive property, but it is not. And we will see when we start using exponents with full polynomials, if we view it as the distributive property, that will get us into trouble. So please know that's not the case. So if I had, let's say, for instance, xy squared, then what I'm saying here is xy times xy. Well, x times x is x squared, and y times y is y squared. So hence x squared, y squared. That's what's really going on. It's not this 2 goes on both. Exponents do not distribute. Bold that, highlight it. It's important. It's not the distributive property. It looks like it, but it so is not. Okay, so in this case I have 2 times 3, and then to the 4th power. So what this is saying, it's saying 2 times 2 times 2 times 2 4 times, and then 3 times 3 times 3 times 3. So hence 2 to the 4th times 3 to the 4th power, and then that would come out to be 1,296. The next property is the negative exponent, and basically all this is saying is that if we have a negative on our exponent, it's going to flip sides. So here I have a to the negative m, and to evaluate the negative, we would flip. So this would be a over 1. So these would flip. I would have a to the m on the denominator, and then the 1. And once we evaluate that, that evaluates the negative. So we see that the m is positive. And we have to add the restriction that a cannot equal to 0, because then we'd be dividing by 0. So if I had 7 to the negative 2 power, I could evaluate that as 1 over 7 squared. and that takes care of the negative, equals 1 over 49. So we always want to evaluate negative exponents. We do not want to have any negative exponents in our answers. It's just bad form. Likewise, if I had, let's say for instance, I'll come up with another example here. If I had 1 over 3 to the negative 2 power, then this would flip and I'd say, oh, well, this is 3 squared, which is then 9. So it can flip in either direction, either way. Zero exponent, a to the 0th power is equal to 1, provided that a is not equal to 0. So basically anything to the 0th power is 1. So I have negative 89 to the 0th power, it's 1. If I have x to the 0th power, it's 1. Question, why is that? Why is it that if we have something to the 0th power, it's equal to 1? Second question, why do we have this restriction? A is not equal to 0. I want you to think about those. We'll address that in class later on. The quotient of powers is basically if I have a to the m divided by a to the n. So if we multiply, we add them together like up here. So if we divide, we're going to subtract the denominator from the numerator. So m minus n in that order. Again, a cannot equal 0. So if I have 6 to the negative third divided by 6 to the negative 6, well, it's going to be 6 to the negative 3 minus negative 6. So in that order, and that's going to give me 6 cubed, which is 216. Another thing I want to point out is that the bases have to be the same here. So the bases here are both 6. Okay, so else it will not work. And then the last one is a power of a quotient. So basically we're saying, oh well, if I have a divided by e to the m, a divided by b to the m power, that's going to be a to the m divided by b to the m, such that the restriction that b cannot equal to 0. Again, this is not the distributive property. Here I have 4 over 7 squared, which is 4 squared over 7 squared. It's not that the 2 is distributing. You're just saying 4 sevenths times 4 sevenths. Well, 4 times 4 is 4 squared, and 7 times 7 is 7 squared. Okay, not the distributive property. And that equals 16 over 49. So let's put these to work. So I want to evaluate this expression. Negative 3 squared times 5, and then it's all cubed. One thing I want you to understand about evaluating powers, evaluating these exponents and using these properties, there's no one set way of doing it. You can start with one thing or another thing. It doesn't matter as long as you're following the rules, okay? As long as you're using the properties, you'll get the same answer regardless. So for instance, one way I could go about using this, doing this one is I could say, oh, well, I have negative 3 squared times 5, and this whole thing is cubed. So I could say, well, this is like saying negative 3 squared times negative 3 squared times negative 3 squared 3 times. So I can use the power of a power, well, it's a combination of power of a power and a product of powers, and that's going to give me negative 3 to the 6th. So it looks like we're multiplying it. I mean, in a sense, we are, but it is not the distributive property. And then it's going to be 5 cubed. So then we would figure out what negative 3 to the 6th is. Let's see, and that's going to give us 729. It's going to be positive 729, and then we're going to multiply that with 125. We multiply those together, and that's going to give us a really large number, 91,125. Okay, that would be one approach. A different way I could do this is, let's say, instead I evaluate what negative 3 squared is first. Well, negative 3 squared is 9, and then times 5, and the whole thing is cubed. So then I could say, well, that's going to be 9 cubed times 5 cubed, and 9 cubed is going to give me 729, and so I'll have 729 times 125, and when I multiply those two amounts together, it gives me the same 91,125. Or I could have simply just said, oh, well, what's 9 times 5 is 45, and then 45 cubed is going to give me 91,129. So there are different ways we can do that, just to show. The next one, again, we can take different approaches. As long as we're using the properties, we'll be good. So, for instance, one way is I could evaluate, 1 to the 4th power first, and that's going to give me 1. And then 3 squared is 9, and then this whole thing is to the negative 2. So this is like saying 1/9 times 1/9, so that's going to be 1, but it's going to be to the negative 2 power, and then 9 to the negative 2 power. So the negatives cause them to flip sides, so that's going to be 9 squared over 1 squared, which is just going to give me 81. Okay. I could have done it a different way. I could have gone and taken care of the power of a quotient first and said, well, that's going to be 1 to the, let's see, that's going to be negative 8 power, and then 3 to the negative 4th power. Because of the negative exponents, they flip sides, they switch, so this goes in the denominator goes into the numerator, and the numerator goes into the denominator. And 3 to the 4th is 81, and 1 to the 8th power is just 1, so it gives me 81. All right, so different method, same answer. Okay, so this next question deals with scientific notation. So here's a little refresher on scientific notation. It states a swarm of locusts may contain as many as 85 million locusts per square kilometer and cover an area of 1,200 square kilometers. About how many locusts are in each swarm? So I'd define my variable. I would say let L equal the number of locusts and the number of locusts is basically equal to the quantity of locusts per square kilometers, or how many locusts are in each square kilometer times the number of square kilometers. So there are 85 million locusts per square kilometer, and we're going to write that in scientific notation. Now remember, scientific notation, you're going to have your first number, and it's got to be between 1 and 10, okay? It's going to be, so it would look like this. We'll call it A. So it's going to be less than or equal to 1, but less than 10. So I'm going to write 8.5, or actually, let's present it this way. 85 million, big number. So we're just basically saying a big number times another really big number, but not quite as big. But multiplied together is going to give us a really big number. And when you start dealing with the really, really large and the really, really small, it's easier to do that in using scientific notation. So I'm going to write this in scientific notation. So again, I want to make my value a, so it's going to be a times 10 to some power n, okay? And this value has to be between 1 and 10. So basically, this is where I move the decimal. We count 1, 2, 3, 4, 5, 6, 7. So I have to move it 7 places to the left. I'm going to leave it between the 8 and the 5 because that's going to be 8.5, which is between 1 and 10. So it's 8.5 times 10. And since this is a really, really, really large number, we're going to have a positive exponent of a positive 7. If it's really, really, really small, then it's going to be a negative 7. So if we have to do 0.000 something, then we use a negative number to represent the really small. Likewise, I'm going to multiply this, and I'm going to put this one in scientific notation. So I'm going to move this 1, 2, 3 places, and that's going to give me 1.2 times 10 to the third. And now I'm just going to multiply these together. So I'd multiply the a values together, and that's going to give me, let's see, that's going to be 10.2. So 10.2 times, and then I'm just going to multiply 10 to the 7th with 10 to the third. So remember, we add the exponents because we have 7 tens here plus 3 tens gives us a total of 10 tens. So 10 to the 10th. But we want to write our answer in scientific notation. Notice that this is larger than 10. So I'm going to have to move the decimal one place, meaning we're going to have to change this. We're going to have to add 1 to it. So L is equal to 1.02 times 10 to the 11th. Okay, so then we do our therefore statement. Therefore, there are 1.02 times 10 to the 11th power locusts in the swarm. And so that's basically 1.02 with 9 zeros behind it. That's a really big number, a lot of locusts. Our next question, okay, so we'll be simplifying using our rules. So we'll try a few of these. So I have w to the 5th times w to the negative 8th times w to the 6th. Okay, so again, there's more than one way we can do this. All right. Remember, when we're multiplying these together, we can add the exponents together. So I would say, okay, well that's going to be 5 plus negative 8. So basically I'm saying this is equal to w, and it's going to be 5 plus negative 8 plus 6, which is going to give me w to the third. Okay. Or I can take a completely different route just to show you what this would look like. Because this middle w has a negative exponent, it could switch sides. So I have w to the 5th and w to the 6th. divided by w to the 8th. So I'll have w to the 11th in the numerator and w to the 8th in the denominator. Then I would subtract these, w to the 11 minus 8, and then that's going to leave me with w to the 3rd. So a different approach using these properties, get the same result. Okay, the next one, let's see, B. Let's take a look at this one. So I'm just going to try one approach with this, and then I'll let you determine what would work best for you. I'm going to go ahead and use the product of a quotient here. So I'll rewrite this as c to the negative 2 over d to the positive 8th. And then I'm going to evaluate the negative, so it's on the c, so it's going to flip sides. So I'm going to have c squared over d to the 8th. And that's it. For c here, I notice I have a term on the numerator and an a term in the denominator. There's a couple different ways you can deal with that. So one way is, I would say, well, I have a to the negative 3, and then I'm going to subtract 5 from there, and then I have the b squared. Okay, so that's going to leave me with a to the negative 8th b squared, which then I'll be left with b squared. When I evaluate the negative exponent, I'll have a to the 8th in the denominator. Okay, that would be one way. A different way to view it would be to say, okay, well, I can evaluate the negative first instead of the division first. So I have b squared, and then I'm going to have a cubed, and then a to the 5th. And then I'll have b squared, and then I multiply those together, which gives me a to the 8th. So as to which is the best way, every problem's unique, every problem's going to be different. You just, use the properties. Maybe you'll find a very easy way. Sometimes it might take a little bit more work, but with practice, you get better at it, like anything else. So let's do one more. I'm going to simplify this expression. I'll just do it one way. Again, there's more than one way to approach these. I'm going to go ahead and take care of the power of a quotient first. So I'm going to take care of this 3. So I'll have a to the 6th, b to the negative 3 over, so this is like saying 2 times 2 times 2, or 2 cubed, and then this is saying a cubed times a cubed times a cubed, which is a to the 9th, and then b squared times b squared times b squared gives me b to the 6th. Okay. Then I will evaluate my division. So here I have a to the 6th, and I have a to the 9th in the denominator. So up here I'll have a to the 6th minus 9, and b to the negative 3 minus 6 over 2 cubed equals, so in the numerator we'll have a to the negative 3rd and then b to the negative 9 over 2 cubed, which is 8. And because these both have negative exponents, they'll go in the denominator, leaving just a 1. And then I'll have 8a cubed b to the 9th. And that will be my simplified expression. So that is how to use the various properties of exponents to simplify expressions. I'll see you on the flip side.